Hey everyone, good morning. Today we are going to talk about building a scalable mobile application with a modular architecture. And we will start from defining what is a scalable mobile application to understand what do we want to achieve. And after that, we will go through the story of Wix, and I will explain how at Wix with React Native we achieved the architecture that enables for each one of the 80 mobile developers to work almost independently. During this talk, we also understand how React Native works, what its benefits, what its challenges, and what is the current state of this framework. So let's start. My name is Lev. I work with mobile in the past 7-8 years, mostly with Android. And in the past 3 years, I'm working mostly with React Native and Android at a company called Wix. If you are not familiar with Wix, at Wix we are building a platform for managing businesses, starting from building an awesome website. It's a website builder. And even the official website of droidCon built on our platform. In addition, we have a mobile app that's called also Wix. With this app, our users can manage their businesses and their websites on the go. But not only. They can also, even if they don't have a website, create something called a digital place and manage and communicate with a community of users through the app. And also, the community of users, the members, can download the app and communicate with their favorite businesses based on Wix platform. So let's start. As I said, let's first try to define what does it mean scalable mobile application. When I thought about it, I eventually got this sentence. It's our ability to grow without compromising on the development velocity, and the ability to increase the development velocity without compromising on the quality of the application. In other words, we want to be able to join more developers to our teams, develop more features without affecting the time to production of these features and the performance of our application. Sounds easy. Let's see how we can do this. When we are building an app and our team is small and our app is kind of small, we can manage the development process of a feature without interfering the development process of other feature. But as our app grows and our team grows, it's becoming more and more difficult. And our build times are longer. It's more complicated to test independent piece of code in an isolated environment, and in general, the work becoming more and more difficult. So what we can do, we can split our application to pieces of code, to models, that each model is encapsulated a piece of code that is independent from other model. And let's understand quickly what we get from this modularity. First of all, the independent way of work. One team should not be dependent on other team's work. And the responsibility of any piece of code should be really, really clear who is responsible for this piece of code. Second, when we change a specific model, we need to build and test only this piece of code, this model, and the models that are dependent on that model, and not on the whole app. In addition, same rule can be applied on the deployment process. In some frameworks, we can deploy only the pieces of code that were changed and not the whole application to the users. For example, dynamic features in Android or in JavaScript, it's also not a problem to deploy piece of the JavaScript bundle. In addition, we get a better separation between the infrastructure code and the business logic code when we have separation to models. And it's becoming really, really easy to replace infrastructure code with some third party if we find something better on the open source, or if our infrastructure is very good and we want to share it with the world, it's very, very easy to open source infrastructure model when it's decoupled from the business logic, because we don't care to share it. And the fact that we are working in a modular way, it's becoming much easier to work according to the old Conway law that stands for that our system architecture should reflect our organization structure. And I'm sure if you look on your architecture, it probably will reflect the teams that you are working in. And if it's not, think about it. Now that we have kind of architecture, modularity, we need to pick the right framework that will support this structure. And actually, it can be done with any framework. It can be done with Android, with libraries and AARs. It can be done with pods in iOS, and it can be done in JavaScript with models, NPM models. But when we started and we looked on the native front-end development world, we saw that a company that wants to develop a good product and target to the main three front-end frameworks, Android, iOS, and web, need to maintain three different teams, which in each team there are experts in different fields. We will have iOS team with experts in Xcode, Objective-C, Swift, and pods, and etc. We'll have Android team with experts like you, and we will have an JavaScript team with experts in JavaScript, React, Angular, and etc. And there is two main problems with this model. First of all these teams implement almost the same business logic, the same functionality, but we are not able to share code between the teams. And second, maybe even bigger problem, we are not able to share resources between the teams. It's very, very rare that a good Android developer is also a good iOS expert. I'm sure there are a couple here. But I cannot give to an Android developer to develop an iOS application. And what companies are doing there have to compromise. They can compromise on time and money and really maintain three teams like most of the companies do. They can compromise on one of the platforms and, for example, develop first the iOS application and after that catch with the Android application, or vice versa. Or they can compromise on the quality of the application and choose solutions that are based on web views such as Cordova and PhoneGap that are trying to simulate the native views with JavaScript, and we all know that the result is shit. So, about 4 years ago, 4 years ago, Facebook, the guys at Facebook, realized the same problem, and they understood that it's really, really difficult for them to scale in the scale they are working. So they decided to develop a cross-platform framework called React Native, and we at Wix joined their journey. So let's understand what is React Native. In the next few slides, we'll understand how React Native works and what is the current status of React Native. So React Native, in one sentence, it's a framework that enables us to write applications with JavaScript and React, targeting different platforms, but still using the native UI building blocks. For demonstration, we will have a small app with one button. Like, we'll click on the like, it will turn to dislike, and again, to like. And for those who are not familiar with React Native, this is how it looks. This is the only JavaScript code that you will see in this presentation, only code. So let's go quick over this code. First, we will import the components that we would like to use in our application. In this case, it's image for images, text for text. Touchable opacity is something like button. View is kind of view group, some kind of container. And style sheets, it's not interesting for now. We will create a constructor, and in the constructor we will initiate our state to false, meaning disliked. We will define the on-press button that will turn the state from false to true and vice versa. And we will implement a method called render that will return a representation of our UI. We define the UI in React with a syntax called JSX. It's a syntactic sugar above JavaScript. And it's very similar to HTML, to XML. It's very readable. And React, the framework, guarantees that this method will be called each time the state is changed, meaning our UI is a function of our state. And this is the whole React in 2 words, in 1 slide. And to make it clear, when we define the image there, eventually the class that will be responsible for rendering this image on the screen is the familiar image view from Android SDK and the familiar UI image view from the iOS SDK. To understand how this magic works, we need to dive in a bit to the React Native framework architecture and see how it looks like. To simplify this, we can divide the React Native framework into 2 layers. First layer is the native layer, implemented with Java for Android and Objective-C for iOS. And it consists of something called native models. It's models that are responsible for some infrastructure functionality that needs a native API from Android SDK or from iOS SDK, or something that we cannot implement in JavaScript because some JavaScript limitations. Above this, we have a C++ glue layer that connects us to the JavaScript layer, which is actually an API that's exposed to the React Native developer. And React Native developer implementing his business logic and using this JavaScript API. Unfortunately, React Native not covering all the Android and iOS SDK. For example, notifications are not covered in React Native out of the box. Same, all the work with camera and other stuff. But React Native is extendable framework, meaning we can implement our own native models in Java and Objective-C or Swift or Kotlin, whatever, and add some JavaScript API to expose this functionality to the business logic layer. Let's see how it all works and compiles and runs on our application. So the native code, the Java, Objective-C, C++, whatever, compiles as normal native application to bytecode. And the JavaScript code going through a process called bundling, which is actually optimizing our code for the JavaScript engine that will execute this JavaScript. In general, what it will do, it will remove all the unneeded code that is not used by JavaScript, and usually will combine all our JavaScript to one big JavaScript bundle file. All this packed inside an APK, and the JavaScript bundle packed inside the assets folder. And when we run this APK on the device, the native code will run on the native side as normal native application, and the JavaScript code will be executed by the JavaScript virtual machine, which in case of React Native is the JavaScript core, Apple's JavaScript core. On iOS, this engine comes from the operation system, and on Android, it comes as a dependency of React Native. And now we have these 2 realms, the native world and the JavaScript virtual machine. The native world is like any native application. We have the main thread. If we want, we can use background threads, and it's responsible for rendering our UI and for the user interactions. And on the JavaScript side, the JavaScript runs in a single-threaded way as JavaScript. And between them, we have the React Native bridge, which is a way to communicate between these 2 realms with JSON messages that need to be serialized and deserialized on each side. And this is the way we can invoke methods from native into JavaScript and vice versa. Very simple. How we benefit from React Native. So first of all, we can actually share code between Android and iOS, and sometimes with web. Not the view layer, but the business logic, because the view is totally different between web, and we don't want to bring it to mobile. We can share developers. It's pretty easy to take a React developer, and after, I don't know, 1 week of onboarding, he can really write a mobile application. He will not fully understand how it works under the hood, but he can implement and it will work. Our development cycles are becoming much shorter because we don't need to compile the full application. We only change the JavaScript, and we have working hot reloading and we see the changes immediately on our simulators and our emulators in Android or devices. And the fact that our business logic is in JavaScript enables us to deploy the code directly to users without going through App Store and Google Play Store. Because our business logic in JavaScript, and this is what changes mostly, we don't need to recompile the native code each time. So we can directly send to our users the JavaScript bundle. And this enables real continuous deployment in mobile, something that we are lacking in the native world and exists in server and web. Like in scale, we want to change the code, throw it to production, see the reaction, and change it accordingly. And maybe the most important thing, now our teams are from being platform-aware teams, they are product-oriented teams. We don't have an iOS team and Android team. We have mobile team. But all this great stuff comes, of course, with a cost, and React Native is a new framework, and it's challenging. It's only now in version 0.6. It's even not version 1. There are often updates of the framework almost every month, and sometimes there comes with breaking changes. And there is not enough development experience because it's a new framework. There are not enough profiling and monitoring tools. There are not enough best practices of big companies. In addition, it's incomplete, as I said. It's not covers the full Android and iOS SDK. And that means that we need to develop our own infrastructure sometimes, or be dependent on some third parties' libraries, and dependencies are always a risk. And another thing is performance, and we have some architecture bottlenecks in React Native that are, as we grow, we see more and more performance issues. As our features are becoming more complicated, we struggle with more problems. And I want to show some problem that is an architectural problem of React Native. Small example. For example, we want to develop a dialer like you familiar from your phones, and we want to add the dash after the fourth digits. Like we want to add it after the user clicked the fourth digit, and we want to put it before the fourth digit. So on Android, the code will look something like that, and this validation will be executed on the main thread before the digit is actually rendered on the screen. And the result is pretty good. We are all familiar with this. In React Native world, because the rendering native world is decoupled from the business logic where we do the validation, the JavaScript world, and the communication between these two worlds are asynchronous, we can get this situation. If our JavaScript thread is busy and our bridge is busy, the validation will be not quick enough to update the dash and put it before the digit. Eventually, we'll get the right text, but the way to this text might be laggy. And this is something that we cannot fix because bottleneck of the architecture. The React Native bridge is problematic. But more and more big companies adopt React Native. Companies such Facebook, Microsoft, Amazon, Skyscanner, Wix, and their challengers are bigger, and they require more strict performance. So they pushes the framework to a better place. So React Native team understood this challenge, and they understood they cannot fix it. So they decided to do now, currently they are doing this, a totally new architecture of React Native, and they decided to remove the bridge. We will not dive to the new architecture of React Native because it's a different talk, but the idea that the state of React Native is always evolving and going to a better place. In 2 words, instead of the bridge, of the asynchronous bridge in React Native, we will have asynchronous and synchronous communication between the native world and the JavaScript engine by adding a JavaScript interface layer between the 2 worlds and direct communication between these 2 worlds and not through the bridge. To understand how it really works, we need to look on the runtime environments of React Native. In Android, we have the Java code that runs inside the ART, the JVM. And part of the JVM, we have the JNI, the Java Native Interface, with which we can communicate with the C++ code on the host device. The same thing, the JavaScript runs in the JavaScript engine, which is written in C++, and expose the JS context, which is our gateway to the host machine, to the C++ code. And in such way, through C++, these 2 worlds can communicate directly, and we actually don't need the bridge. The bridge is kind of 90s architecture. Let's go back to the modular architecture that we want to implement. Now that we understand how React Native works, the state of React Native, and why we picked it. So in our architecture, we want to support 3 kinds of entities. First of all, we want to be able to develop an encapsulated library, which is responsible for some infrastructure functionality. For example, dealing with notification or dealing with camera functionality. There is no business logic in this library. Second, we want to be able to develop an encapsulated piece of code of business logic, and this will be a feature model. And third, we want to develop, we defined it, something called an engine. This is actually the core of the application. And it's empty application that knows to receive some configuration and load models according to this configuration and provide all the needed infrastructure to these models. It will look something like this. The engine will bring as a dependency libraries that we would like them to be only one instance in our application, one version of these libraries in our application. And the engine can receive an configuration, which models he needs to load, and load these models according to this configuration. And of course, each model can bring his own libraries, but only the JavaScript libraries, because we cannot allow that every model will bring a different version of native dependency. Otherwise, this will not compile. You can think about this architecture as, for example, Chrome and extension. The Chrome knows how to load the extensions. The extensions don't know about each other. And actually, the Chrome don't care about what these extensions are doing. It just provided some API. There is some contract between the extension and the browser. So this is a very similar idea. An example for a library that we have is our components library, the React Native UI lib. And it's a library, all our application all our developers must use the components from this library. And this library is developed by a team of experts that are experts in building UI components in a generic way that will suit everyone. And in that way, we are improving the development velocity because the other teams don't need to deal with building the UI components. And we avoid we avoid the situation that we have lots of different buttons in our applications. So the internal consistency of the application is preserved. And of course, it's open source because it's don't have any business logic, Wix business logic. We can open source to the world. And we are doing this with lots of our infrastructure, libraries, and development tools. The engine, let's look what we have inside the engine. Inside the engine, we have native code, Android and iOS. And inside the package.json of the engine, package.json is the file where we define the dependencies of our project in the world of NPM. NPM is the package management system of JavaScript ecosystem, like kind of Gradle. And in our package.json, we will define all the libraries that we would like to use. Most of them will have native code. For example, React Native Camera Kit deals with the functionality of the camera inside React Native application. In addition, when we build the engine on our CI, we also build the APK and the APP file. And the APK file is part of the artifacts of the engine. Why we are doing this? Because we don't want that every developer will build the native code on his machine. We want to increase the development velocity, and the JavaScript developers will only execute the APK or the APP file, the iOS file, and inject the JavaScript code to this APK. So everyone are working with the same APK, and they changes only the JavaScript code. A model is a feature model. We don't have most of the time, we don't have native code in the model in our business logic. We have only JavaScript. And inside the model, we will have a file called model.js, which is actually a contract between the engine and the model. For example, what does it mean, a contract? For example, a method init will be invoked. It's guaranteed, the engine guarantees us that for each model, a method init will be called when the app is start. So if a developer wants to put some logic on the startup of the app, he will put it in the init method. The same, for example, the methods. If some model wants to expose some method to other models, he can return it in the methods, and the engine will call this method and register it inside the engine. So other model will be able to call this method. And we have the master repo, which is actually only a list of dependencies of our application, which is our models and the engine. And the GA, stands for general availability, meaning production ready. It's a tag. Instead of versions, we can write in NPM tags. So when our model is tagged with J, it means that it's production ready and it can be shipped to the users. Let's understand how the development process works from the point of view of a single developer in the team. So a developer will work with the engine and the libraries, and it will work only with his own model. He will tell the engine, load only my model. I don't need the other models. So the developer works in the environment when he is dependent only on the engine and the infrastructure libraries, and not dependent on other business logics or other teams. So our developers are coding. They're pushing the code to GitHub. their models are built in we're using TeamCity mostly, and this model is published to the local Wix NPM repository. After, when the developer thinks that he coded enough and his feature is ready and he wants to see how his feature acts as part of the whole application, he will tag the latest version, the version that he thinks that is a release candidate. He will tag it as RC, release candidate, and this will trigger a compilation of the whole application with all the rest of the models when they are tagged as GA, they in the stable version. And the result will be an orange application, at Wix, orange application meaning internal application, and we distribute it with a service called Hockey App, and it's from November it will be called App Center. And when developer product QA test their feature, the new feature, and the model that was changed, and they decided that this model is ready for production, you just need to tag its version to GA, general availability, and this will trigger a build of a purple application, a production-ready application, in which all the models are tagged with GA, and also the engine, and tagged with GA, yeah. And this will be uploaded to the test flight, to the Google console, and after a very quick manual QA, we are trying not to do manual QA. We have end-to-end automation test in React Native based on Espresso and Earl Grey. And after a quick manual QA and approval from a release manager, this application can be released to Google Play and App Store. So to summarize what we have now, we really share code between Android and iOS. We can share about 80% of our code between the two frameworks, and sometimes we also share code with our web teams. We are about 80 mobile developers in the team. It's a lot of developers, and we are spread across 6 sites, across 3 countries, across 20 different teams. And we all work almost independently. We still need native developers, of course, because as you saw, React Native, it's not fully JavaScript. We need native infrastructure. So about 40% of our team has a background with Android or iOS. And it's really, really easy for us to scale and recruit developers from the JavaScript world or to take someone from the web teams. And after a quick, short onboarding to the mobile world, he will be a great mobile developer. And with this architecture, we are able to release a new version to production almost every day. And every developer from the 80 developers can decide that he needs to release a new version to production. That's all. Thanks.